Welcome to the lecture on QPSK, quadrilateral phase shift key. In the previous lecture, we have seen the BPSK scheme. BPSK, where we have a carrier root 2 by t cos 2 pi fct. This is phi of t. And to transmit one, you will be transmitting root e phi 1, and to transmit 0, you will be transmitting minus root e phi 1, phi, okay? Or we can say to transmit 1, you are transmitting root 2 EB by TB cos 2 pi FCT, and to transmit 0, you transmit root 2 EB by TB cos 2 pi FCT plus pi. That is, to transmit 1, you will be sending the carrier as such. To transmit 0, you will be phase shifting the carrier by pi and then transmit. This is in the case of BPSK. There you have only 2 symbols to transmit. In quadrilateral phase shift keying, you have 4 symbols to transmit. Okay, so what you will do is, here you had only 2 phases, 0 or pi. Here in QPSK, you will use 4 phases. Each are equally separated. Okay, you will be using 4 equally separated phases for the carrier to transmit 4 symbols, and these phases are separated by a phase of pi by 2. Okay, pi by 2. So these are separated by pi by 2, these are separated by pi by 2, and that like that. So to transmit a symbol, you will be sending this signal Si of t root e by t cos 2 pi fct plus 2i minus pi by 4. Okay, so to transmit S1, you will be transmitting a phase pi by 4. That is, I is equal to 1 here, then you will be transmitting a phase pi by 4. To transmit the second symbol, that is second symbol, you will be transmitting S2 of t. Here then you will get 3 pi by 4. Similarly, 5 pi by 4 and 7 pi by 4. So you have 4 symbols to transmit: M1, M2, M3 and M4. You have 4 symbols to transmit. You can encode it like this: 0, 0, 0, 1, 1, 0, 1, 1. An encoding. You can use a different encoding as well. 1, 0 here, 1, 1 here, 0, 0 here, 1, 0, 1 here, like that. Okay. Now you see that in this case, when you send a signal, you will be sending only 1 bit. That is, 1 is represented by this and 0 is represented by this. But in this case, when you send a signal, you will be sending a symbol, say M1. That is, you will be transmitting 2 bits at a time. Each phase corresponds to 2 bits of transmission at a time. That's why it's called bandwidth conserving modulation scheme. Okay, so here I have Fc is equal to Nc by T, as we have already seen in the case of BPSK, just to ensure that you have integral number of cycles in each symbol duration. Okay, so each possible phase corresponds to a unique bit, that is a pair of bits that we have discussed. Now to see the signal space diagram of QPSK, do one thing, that is, this is root 2 EB by t e by t cos 2 pi fct plus 2i minus pi by 4. We can use the trigonometric identity cos a plus b here. Cos A plus B is equal to cos A cos B minus sin A sin B. Just use that identity here and you will get this. Now take this one, cos 2 pi FCT together with root 2 by t. Okay, that is this one. Again take this one, the root 2 by t sin 2 pi FCT as phi 2. These are an orthonormal set of basis functions. Okay, if you take the inner product between these two, it will be 0 because one is cos and the other one is sine. They are at 90 degrees, so the inner product will be 0. They are orthogonal. In fact, cos and sine are orthogonal. And again, this one will have unit energy, as that we have already seen in the case of QPSK. So you have, from this you can find two basis functions. One is phi 1 this and phi 2 is this. Now using the basis functions, you can represent the signal as this. If you are transmitting symbol 1, that is I1, the signal S1 can be written like this: root E by T cos pi by 4 cos 2 pi FCT. Okay, so see here, you have 2I minus pi by 4. I is equal to 1. So finally you reach up to here, root E by 2 phi 1. So this is phi 1 and this is phi 2. So root E by 2 phi 1 minus root E by 2 phi 2. If you write the signal vector of S1, the signal 1 is equal, this is equal to root E by T minus root E by T. Okay, phi 1 is a cosine, this is a sine. Both are at 90 degrees. Okay, phi 1 and phi 2 are orthogonal, and this is called in phase channel and this is called quadriphase channel. This is in phase channel and this is the quadriphase channel. Okay, similarly you can put I is equal to 2, I is equal to 3 and I is equal to 4 and find these signal vectors. In general, the signal vector will be represented by this, see, in terms of I. Okay, now to see the signal space diagram of QPSK, suppose I have used this encoding for my message symbols. Okay, I have 4 message symbols M1, M2, M3, M4 to transmit. Okay, M1, to transmit M1 I will use a carrier with phase pi by 4. Transmit M2 I will use the carrier with 3 pi by 4 and M3 here this and M4 7 pi by 4. I have used a gray encoding to represent my symbols. So this is 1 0, this is 0 0 and this is 0 1 and this is 1 1. I can use a different encoding as well, but this encoding has an advantage that we will see shortly. Now see that M1 corresponds to pi by 4 and the signal vector is this, root E by 2 and minus root E by 2. See here, the signal vector S1 is root E by 2 minus root E by 2. So this component of signal vector root E by 2 and minus root E by 2. Again here 3 pi by 4, that is minus root E by 2 minus plus plus plus. Okay, now if you analyze this bit stream and the signal vector, you can see that the 1 is always represented by root E by 2 and 0 is always represented by minus root E by 2. If you get a 0 here, you will get a minus root E by 2, and if you get a 1 here, you will get plus root E by 2 here. Similarly, in this position as well, if you get a 1 here, you will get root E by 2 here, 0, then minus root E by 2 here. So there is a mapping, one-to-one correspondence between this position and this signal vector and this position and this signal vector. Okay, so to generate a QPSK signal, what you need to do, take the debit. Okay, now find what is coming in the position B0. If it is 0, then si2 is minus root e by 2, and if it is 1 it will be plus root e by 2. And similarly examine the position b1 and find this signal vector element. Okay, now the signal space diagram. This is a signal space diagram. You have two bases, phi1 and phi2, and this is my first message point. What is first message point? M1 is plus root e by 2 and minus root e by 2, plus root e by 2, minus root e by 2. So this is my point. Similarly, we can find the other points too. This is an example of QPSK signal waveform. To do that, what you need to do is, this is a stream of bits. I will pair the bits. Okay, I'll group the stream of bits into two. Okay, so the bit in this is B0 position and this is B1 position. Here this is B0 position and this is B1. B0, B1. Now let me separate B0 and B1. This is B1 bits and this is B0 bits. Okay, B1 and this is B0. Now how can you generate the QPSK signal? If you have 0 here, generate this. If you have 1 here, okay, so this is your signal vector. So multiply this with phi1 and this with phi2 and add. That's how we generate QPSK signal. So si1 phi1 plus si2 phi2. Okay, if you see this is an independent BPSK channel. In BPSK, what is BPSK? You will be transmitting either root TB phi1 or minus root TB phi1. This is for 1 and this is for 1 and this is for 0. Similarly here, okay, if you take this part, that is this one, okay, if you have a 1 here, you will be transmitting root e by 2 phi 1. If you have a 0 here, you will be transmitting minus root e by 2 phi 1. And if you take this position, if you have 1 here, you will be transmitting root e by 2 phi 2 and 0 minus root e by 2 phi 2. Okay, so these are two independent channels. These two independent channels added together will give you QPSK signal. So that's what we are seeing here. So you have two independent channels. So this is B1 channel, okay, and this is the B0 channel. Now what you have to do is 0 should be represented by cos function multiplied by minus root e, right? Cos function multiplied by minus root e. See, what is si1? This is cos 2 pi, that is root 2 by t cos 2 pi, and this is either root e or minus root e. If it is 1, it is root e. If it is 0, it will be minus root e. That is, you have a cosine signal. Okay, this is a cosine signal. Okay, but here you have 0. Then the 0 should be represented by a negative cosine signal. That is, you need to multiply this cosine with minus root e. That is negative. Just simply neglect this root e here. You can say that it is a negative cosine. Negative cosine means this cosine inverted. That's what here. Okay, so 0 in this time duration you have 0. So you will be sending a negative cosine. And in this time duration you have 1. Then you will be sending a cosine. You send a cosine here. Again in this duration you have 1. You will be sending again a cosine. Here you have 0, then negative cosine. Similarly, you take the even numbered sequence, that is B0 sequence. For B0 sequence, the basis is sine 2 pi fct. The basis is a sine function. Here you had a cosine basis. So you have a cosine. So you have a cosine, then inverted that to represent 0. But here for even numbered sequences you have phi 2, that is a sine basis. So a sine basis. And if you have a 1 there in that position, you will be sending the sine. If you have a 0 there, you will be sending a negative sign. Okay, minus sign. So in this position you have 1, in this duration you have 1, so you'll be sending a sign. Here you have 0, then you send an inverted sign. Again here you have a 0, so you send an inverted sign. Again 0, so you have an inverted sign. Okay, what you have to do now is simply add these two together. Okay, this one plus this one will give you this, and this is the QPSK signal. Okay, thank you.